Hello everyone, I am architect Mustafa Küçük, the first author of this article. I attend the Congress from Istanbul University, first organizing committee and chairman on the conference earlier and everyone thanks. I want to present you a part of my article. The presentation these titles: Abstract Introduction, Definition, History and Advantage of Diagrid Structure, History of the Gherkin Tower, Interaction Structural System with Architectural Design in Gherkin Tower, Conclusion. We start with abstract. Abstract. 21st century witnessed enormous technological developments affecting architecture, also improved building materials and construction techniques, highly innovative development of structural systems using advanced computer software leads it to significant novelties in the built environment worldwide. The diagrid structure having a hyperboloid form of which the first design and implementation was applied Victor Hugo in as early as 1896, but due to the Diagrid and its doubly curved form, it provides to achieve greater later strength, rigidity, and efficiency than rectangular frame system, decreasing the amount of the required materials besides offering the possibility of prefabrication and easy and assembly. Although the first Diagrid structure was built in 1965, the IBM building in Pittsburgh, it didn't use the double curved form. The system was not widely recognized until the Gherkin Tower, designed by Sir Norman Foster, was completed in London in 2003, displaying the twinning of architectural and structural design. You can see keywords. Let's start introduction. Introduction. Depending on the increase in the population from the past to present day, new shelters have been needed and the need has increased greatly as the result of the growing urban space and intensive user requirements. The number of space increased and space width increased greatly. In the beginning, wooden and stone materials were used to pass lifespan and the roofs were crossed with domes. Then with the discovery of steel and the new developments which are making steel harder, more durable. Steel changed the history and became the basic material of structural science from at the present by giving direction to whole civilization and the way of life. Especially after the industrial revolution, the construction of high buildings increased rapidly to the increase in the population in the cities and the decline of the land building built, and even high buildings and skyscrapers became symbol of the power of the state. In the race of power with the contribution of technology and material science, the construction of high structures became easier, and new structural designs were introduced, in which steel was used the main material for lifespan. The most striking of these structural systems is the Diagrid structure system, which is the most widely used today. This system defines combination of the grid and diagonal allows wide openings to be crossed without closed and reduced the number of structural elements. The advantage of Diagrid system used statically high structure or combination or orthogonal structures is that they can achieve great structural efficiency without vertical collapse. One of the main reasons the efficiency is the use of triangular frame instead of rectangular frame because the triangular the most durable geometric shape. Although the Diagrid structure popular today, its history goes back to more than 100 years, and based on the innovative studies, Russian architect engineer Vladimir Shukov, who was pioneered the development of Diagrid structures by applying the doubly curved geometry hyperbology. The first example of the system in the IBM building in Pittsburgh, USA, whose architectural design was Mike Curtis and Davis. At the time building's construction, the Diagrid system could not attract an attention of architects and engineers enough. However, architect Norman Foster's use of the Diagrid structure in his designs in the following years provides the recognition of Diagrid structures to the world. In this study, the Gherkin Tower as most striking and impressive design ever realized with the Diagrid system by British architect Norman Foster, who allowed Shukov's scholarly is examined. In addition, the advantage of structural system and its interaction with the architectural qualities of the building are discussed. 2. Definition, history, and advantages of Diagrid structure. What's a Diagrid? Diagrid is the abide form of the diagonal and grid works. In the Oxford Dictionary, the words Diagrid definition and supporting courage framework system formed by cross-cutting concrete or metal beams. The structural system formed by connected steel structures, which are basically placed in the triangular geometric shape with node points to each other, is a form design developed for the construction of tall buildings and widely used today. The origin of Diagrid. Although the used Diagrid system became popular early 200s, its history dates back nearly 100 years. After the discovery of steel, iron stones were melted in coal mines in the beginning, and the production of steel was provided is the way. But with this method, both in the production was limited and the cost was high. Only cast iron could be obtained in the high temperature furnace newly commenced project. So, the cost was even higher since in required a furnace again to turn in steel. Henry Bessemer developed method to transform the cast iron into steel by reducing the percentage of carbon in cast iron and succeeded producing qualified iron. In this way, lighter steel with higher tensile strength, and superior steel properties than cast forged iron began to obtain, and steel became the dominant structural material from the invention of the steel frame to tall buildings in 18,000s. When technical developments allowed reinforced concrete and steel be used together, iron cage structures were first in the brick construction 18,000. Then it was started to adapt rich reinforced concrete structures to top to make them higher and create lifespans. The 37 meters high Shokov Tower, built in Shakov in Russia in 1896, was built with steel using hyperbolic geometry curve in the was first example of Diagrid structure in the world. He also designs Vaiksa Metallurgy factory in the town of Vaiksa, Russia. The world's first double curved steel Diagrid was used in its roof. This is an IBM building and Shukov Tower and Vaiksa Metallurgical plant. Famous British architect Norman Foster, who derived from the system developed by Shukov, has also used the Diagrid structures 2000s in many of high buildings such as Gherkin and Gherkin Tower and the British Museum Renovation Project. The leading example of the design and construction of the system by Norman Foster are his Tower and Gherkin Tower. In this article, besides the advantage Gherkin Tower and structure, which is of the most successful striking examples of the Diagrid structure, the interaction of Diagrid structure used the building with the architectural design has been examined. One should choose Diagrid. Recently, the use diagonal for structural strength, resistance, efficiency, and aesthetic appearance has created a new interest for architectural structural design. Diagrid systems can also be constructed and improved version of the braced tube system. The main difference between traditional braced tube frame system and Diagrid structures is almost all columns are removed, given space and design freedom in architectural plans. At the same time, conventional structural systems carry only horizontal loads, while diagonal elements in the Diagrid system have the opportunity to resist gravity loads as well as horizontal loads due to their triangular arrangements. Like a structure, the vertical cantilever is modeled as being greater, girder, and divided into longitudinal modules according to repeated Diagrid pattern. What's node? Node is designed connection points for the connection of typically triangular modules on the Diagrid elements. This is a node. Advances of Diagrid structure. Diagrid is a structural system that emerged as a choice of conventional architecture and their various functional and economic advantages underlying system. Thanks to system, higher structures can be built. Large span can be easily formed and used of as roof cover. It allows regular and irregular forms, etc. In addition, it does not require lateral load carrying assistance and extra resistance for lateral loads. It makes possible to reduce the amount of steel used by approximately 20%. 3. History of the Gherkin Tower. Gherkin Tower, also known as St. Mary X, is a skyscraper located in the financial district of London City, near the famous Liverpool Street and Liverpool Market. The important conventional building of London, Baltic Exchange, is destroyed by the bomb dropped by Irish Republican forces in 1992. Then the Swiss Renaissance Company has purchased the area and has the famous British architect Norman Foster designed the building to build of London's most ambitious commercial buildings. At the same time, the historical building around it was restored. The Gherkin Tower, which is built a central, easy access area, was designed by Foster and Partners, an engineering company. Foster wanted the building to be striking, remarkable that stand amounts to 100 years old. Building in this vicinity and in the constant harmony with them. The psychology of design was create innovative and up-to-date form streaming from building technologies and materials. The construction of the curved and angular form skyscraper was started in 201 and completed in December 203 and opened in April 204. After completed its construction, it successfully became of the most iconic and most important urban symbols of the city with its designs in short time. The building was built on the floor area 47,090 and 50 meters square. The building consisting 41 floors built with modern Diagrid steel structure upon the advice of Arab Engineering, is considered a first ecological skyscraper in London. This is a Gherkin Tower section and elevation. Design of notes. Our company that provides engineering services together with Foster in the design of Gherkin Tower preferred the Diagrid system as the structural system in this structure. In designed 360 Diagrid steel module notes to sympathy the construction of angularly rising and curved skyscraper and connect the Diagrid frame. Design of module size. A module of 4 floors from tip to tip of Diagrid is used on the Swiss Red Tower. In this instance, the relevant small module is required in order to allow for the use of straight Diagrid members to achieve the appearance of the curved shape without neglecting the bending of the members. Less steel usage. When considering the efficiency of Diagrid structure, it is important to take very holistic view of the Diagrid buildings such as Here's Magazine Tower and Gherkin Tower have been reported to use structural system still than conventional moment framed wood. Interaction structural system with architectural design in Gherkin Tower. Gherkin Tower, also known as St. Mary X, is the first full Diagrid conventional building. Skyscraper is not only ambitious and interesting building, it's one of the sustainable green buildings with the architectural and structural system design. Due to its distinctive form in the heart of the city of London, it is an instantly regularized structure even on the horizontal sky. It has sustainable design that will serve as a model for all skyscrapers in Europe's leading financial centers. It was built with environmentally friendly approach that reduces energy consumption. The relationship of the building, which has a high environmental strategy with the street, is well established by architect. Is disparate from other skyscrapers with its sitting areas, landscapes, elements, and public square. It is lively skyscrapers that urban life interconnect due to the social space domains in the contains. 4.1 Architecture. The architect of building, Forster and partners wanted to obtain an impressive form that manifests itself distinct from the old building around as well as being modern and stylish. In order to create assertive structure angularly rising, the Diagrid structure design emerged with the support of Arab company. The roof of the tower, which is in the circular plan that narrows as what rises from the ground top, is covered with dome. Starting from 38th floor, there are restaurant bar floors with 360-degree panoramic views of the Empire Square to create social environment for office workers and visitors. Although the building is high, structural success has been achieved against wind load. One of the reasons for the success is the desired current result, passing many wind simulation tests while creating the floor building. Compared to rectangular structure, the wind turbulence and pressure levels is low. A social level lying space has been created for people on the ground. As are at the top of skyscraper, there are cafes and outdoor sitting area ground floor. This copy. All of the floor plans with form are differently designed by Foster. Each floor in the skyscraper turns at the angle of 5 degrees. Also, 6 triangular pieces have been removed from the curved circular floor plans and light wells have been built in order to benefit from sunlight in this spans. This is one of the advantages of Diagrid structural system used in skyscraper is that there are not traditional columns in the structure. In this way, clear and spacious areas with large span have been created in the interior. Used area has reached maximum efficiency for office and common areas. Facade. Many Diagrid buildings, especially those with curvilinear form, tend to use triangular glasses on their face. Gherkin Tower is one of the buildings with triangular glass curtain wall facade. The integrity of facade with structure is achieved by using triangular diamond-shaped transparent double-wall glass plate in the form raising angularly. Besides adding an aesthetic value to face design, angular rise of structural elements in the building and the possibility of coming into prominence provide designers convention in phased arrangement. After renovation with phased engineers for skyscraper, it was designed to add the double glazing in the building of 5,500 pieces of glass equal to 24,000 meters square, which is about of size of 5 football fields were used. There 792 mechanical windows that can be opened in the light wells for ventilation and fresh air flow in the building. Considering the climate and weather conditions, the building is naturally ventilated by these folding mechanical glass. In this way, the energy consumption used for ventilation is reduced. The modules are left empty in this entrance part of the building, and the cafe on the ground floor, and the entrance is provided toward this space. Face cleaning. Special methods are required for face cleaning in curvilinear and tilt structures such as Gherkin Tower in London. In order to clean the face of Gherkin, a rotating extendable crane to the top of the tower has been designed. The crane designed for Gherkin runs on the rails set parallel to the building form. With this crane operated and curtain intervals, the exterior of the office building can be cleaned easily. Atriums and lighting. One of the performance targets of Gherkin Tower has been used daylight at the heights level inside the wall structure. In accordance with the disperse, 6 triangles were removed form, the floor story plans with circular form and rotating an angle of 5 degrees and atriums were formed in their two areas. These atriums have light wells that control and purify and the air. Divide the building into fire safe zone. Every 6 floors are combined with a light well. The atriums connected vertically, but each floor divides from the previous level an angle of 5 degrees and forms a spiral structure. By means of the light wells, the people working in the office make maximum use of the daylight that reaches the center, the circular floor plan. The light wells created at the same time have become stress releasing as give space where office workers can relax during the day. The luminous areas provide strong visual connection between floors and create a natural focus for office. Atriums designs on floor connected vertically each other in order to create a series of informational interstitial space that spiral building. Light wells interpret on the every 6 floors, thus it makes easy to cool the air out in the building. Ventilation. The fact of Gherkin towers being equipped with complete double-skin-faced triangular glasses and the opening and closing feature of the windows in the light well areas according to the weather conditions, important pillar ventilation system and important in terms of energy saving air circulation and increasing indoor air quality. The opening of the glasses in the atriums created by in the line with this objective significantly contributes to the ventilation in the building. At the same time, the aerodynamic form of the building provides an economical and sustainable contribution that helps natural ventilation in light wells, significantly reducing the use air conditioning. Extension pressure difference created by twisted vents help the buildings use its unique natural ventilation system. 792 openable mechanic windows are used for the ventilation of the building and the flow of fresh air in the light wells. The blinds are computer controlled to raise or change their tilt depending on input data. The windows of the building are also computer controlled and are designed to open when the external temperature is between 20 degrees Celsius and 26 degrees Celsius and the wind speed is less than 10 mph. Wind resistance. Structure resists many lateral forces such as wind load, earthquake waves, vibrations, especially the structures being forced by wind turbulence formed in the area where structure stands on distributing the comfort of the space are of most important problems to be considered is high-rise buildings such as Gherkin Tower. While choosing the structure and circular form of the building Gherkin Tower, a number of turbulence simulations were made and design was made according to statistical results. As the advantage is its structure, Gherkin Tower resists the limitation of the area with its original form, the circular form of the office building that decreases in diameter as the rise is less massive than rectangular block, creates an urban living space at street level. At the same time, while aerodynamic form the building shows minimal wind resistance, it makes the wind rotate around. This increases the environment quality for people on the ground, reduces the load on structure. Lift system. There are 23 elevators in this 41-story Gherkin Tower office building to provide human circulation. 16 of them are passenger elevators, 2 firefighters, 2 good lifts, 2 shuttle lifts for the top floor, and 1 car park lift. Elevator can carry maximum of 378 people at the time and can travel at the speeds of 6 meters per second. Fire safety. In the event of fire Gherkin Tower, firefighting systems have been developed. In the case of fire in the building, fire warning given automatically heat and smoke detector. Apart from the automatic fire alarm, there are also many manual fire buttons building. A sprinkler system with delivery system at the most 25 meters is used to respond with the fire. Sprinkler was used to 39 floors, but there is no sprinkler system in the dome. The windows in light wells open automatically in case of fire and help evacuate the smoke. At the same time, the atriums in skyscraper employs escape strategy based on the glacial vegetation. It's a safe area for evacuation and projection of the people in the case of fire. Another fire projection in the Gherkin is using special galvanized and fire-resistant particulation to present slashing of fire. Other parts be a central fire control system after the evacuation of people in the area where the fire occasioned. With this fire barrier curtain, the area around this fire is closed automatically and spread of fire is prevented other areas. Energy saving. Estimated X is environmentally progressive building. Its unpromising modernity is allowed to sensitive to natural environment. A comprehensive range of sustainability measures mean that the bulbs will use 50% less energy than traditional prestige office building. Fresh air is drawn up through the sprawling light wells of naturally ventilated office interiors and minimize reliance on artificial cooling and heating. The light wells and the shape of the building maximize natural natural daylight moderated the use of artificial lighting and allows views out from deep within the building. The interior atria are expressed on the exterior by distinct spiral bands of gray glazing. Conclusion. This study focused on examining the Diagrid structural system and advantages which are widely used tall buildings today. Our Gherkin Tower. Throughout the study, besides the advantages of the Gherkin Tower structural system, interaction of the Gherkin Diagrid structure with architectural designs has been examined and supported by fieldwork. Diagrid structures become of the perfect systems for designers and engineers in recent years in the construction of tall buildings where the limits of architecture technology are pushed day by day. The process leading to the Diagrid structure began with the research for more structural capacity with less material, less weight, less cost. Hyperbolic designs of Shukov, together with the relevant calculation, provide this can be achieved by using double curvature geometry both in the planar and volumetric sense. Further research continued to be undertaken about not only conveying larger and larger spans, but also for construction taller and taller buildings, providing the required structural efficiency. One of the results of these researches and relevant implementations, along with the wide use of computer softwares, is the Diagrid structural system. Diagrid structures provide many advantages such as use of much less material due to the double curved geometry and the triangular tessellation, hence reducing the weight of the building, successfully transferring the loads in the structure to foundation through nodes and models, which can be prefabricated and assembled in short time. Therefore, lessening the required construction period, etc. In Diagrid structural systems, load transfer carried out with diagonal beams without need for vertical columns, a factor which one of the most important architectural assets, providing the freedom of space and flexible use. It was observed that among structural steel used by 501 compared to traditional frame system by using the Diagrid structure in Gherkin Tower building, which was examined is detailed in the study. Since the structural materials fabricated and molded easily, the construction was completed in a short 2 years. The structural Diagrid system that reaches the top from the ground has given the face an aesthetic, dominant, and impressive identity besides increasing stability of building. The Diagrid system exhibits the face and an elegant image is obtained by using double-skin transparent glasses, replacing the surrounding wood environment, mainly this historic part of London of which it has become foreign company. The building has set an example for other buildings, or not only with structural and architectural design, but also due to its ecological design, which made it sustainable enough to be considered the world's first green building. Therefore, Gherkin Tower has become the most impressive and striking example of the fact that a structural system can be structural very efficient, can serve sustainability principles, can help ecological of environment, can aid to the aesthetic value of the region toward enriching architectural aesthetic of the building. In Turkey, tendency for construction office and conventional buildings as well, the mixed use once taller and taller has been increasing in recent days. However, the structural system used is almost always the reinforced concrete skeleton system, which makes the building very heavy and messy. Therefore, as the height of the tall building increases, its cast follows it, not adding to its structural efficiency, but not to its weight, which in turn degrades it. As the course of its nature, the skeleton system has many which hinder the privation of freedom in architectural space, let alone the flexible necessary for dealing with possible change of use in the time. In addition, it's regretful to point out the fact that do do care for sustainability and ecological issues are not given in the design and construction of these buildings. On the contrary, most of the time invaluable ecological balance of the environment is damaged. As was shown in the study, the Diagrid structural system can be another alternative for construction that tall buildings in Turkey. Due to its above-mentioned proven advantage, they could be built more economically and faster with this system as criteria successful enough of overcome the hesitance about the materials steel since country imports structural steel for the time being. The author considers that the Diagrid structural system will also allow for different climatically-aware architectural designs since Turkey has 7 geographical regions with different climate features. Therefore, it's accepted that this system, which has not yet been implemented in our country, will be used the feature due to its multiple advantages, underlying the possibility for variety of architectural design. Thanks for your listening.